This is my 1-minute video for explaining Lagrange polynomials of degrees 1, 2, and 3. I'm jumping right to the third degree Lagrange polynomial explanation. So for Lagrange polynomials, we use them when we desire to find a polynomial that passes through the same points as our unknown function. And one thing to remember is the max degree of polynomial is equal to 1 less than the number of points. So here I'm going to look at a set of 4 points of a function where we have x0, 1, 2, and 3 corresponding to f0, f1, f2, and f3. 4 points. This is going to be a third degree polynomial. And we do not assume uniform spacing of the points, and nor do the x values need to be arranged in any particular order. And our third degree polynomial has 4 terms, and it breaks down like this. And each term here is a cubic, and the sum is cubic. And the pattern of each term is to form the numerator as a product of linear factors of the form x minus x sub I. So we omit one x sub I in each term, and the omitted value being used to form the denominator by replacing x in each of the numerator factors. So in our f sub 0 term, we omit x sub 0 in the numerator, and we subtract from x sub 0 in the denominator. Similarly, for our f1 term, we omit x1 in the numerator, and then we subtract from x1 in the denominator. And same for f2 and f3, our third and fourth terms. And then in each one of these terms, we multiply the f sub I corresponding to the x sub I omitted in the numerator factors. So if in the f sub 0, if we omit the x0 from the numerator, we multiply by the f sub 0 function. So, and it's the same for the other 3 terms. And it's, once you write this out, go through this once or twice, it's pretty easy to see that the Lagrange polynomial does in fact pass through each of the points used in its construction. For example, for our polynomial of third degree, let's assume that x equals x2. And then if we look at this, we'll see that all terms but the third will vanish, because if x equals x2, that term goes to 0, so the first term is 0. If x equals x2, this term goes to 0, so the second term is 0. And if x equals x2, this term goes to 0, so f3 is 0. So what we end up with is our polynomial equals f2 times 1. And so our polynomial third degree polynomial equals f2. And similarly, really, we're saying here is the third degree polynomial of x sub I equals f sub I for I equal to 0, 1, and 3. Now this was a third degree polynomial with 4 points, but if you're trying to do a first degree polynomial between 2 points, or a second degree polynomial of 3 points, everything breaks down the same way. The theory works the same for the way you work out your terms and the way that you deal with the numerator and the denominator.